Lesson 2.5, solving equations using multiplication or division. Again, you should be taking notes on this to help you remember it, because if you write it down, it'll stick with you longer. And then, of course, you have a reference. Now, in the last section, we talked about how addition and subtraction were inverse operations. Think of a number, add 10, subtract 10, you get right back to the original number. Well, multiplication and division are also inverse operations there. They undo one another. Think of a number, let's say 5 multiplied by 10, 50 divided by 10, right back to 5. Multiplying and dividing undo one another. Now you have to be a little careful with 0, because you know when you multiply by 0, you always get 0. But if you try to divide by 0, it's undefined. So 0 is the exception to the rule, and that'll be stated in the properties here. Now we're going to look at two more properties. We have the addition and subtraction properties of equality. Now let's look at the division property of equality. If A, B, and C are real numbers, and here we go, C can't be 0, does not equal, this means does not equal 0. And if A equals B, then A divided by C equals B divided by C. You can take equal amounts divided by the same non-zero number, and you get equal amounts. And that allows us to solve these equations. We're going to transform these equations into equivalent equations so that we can get the variable all by itself. Equivalent equations means they have the same solution as the original. So in this case, my variable is x, it's 2x, which means 2 times x is equal to negative 18. I'm going to try to get the variable x all by itself on one side, which means I've got to get rid of the 2 that's times the x. Well, the inverse of multiplying by 2 would be to divide by 2. Now I'm going to write my division like a fraction. I'm going to write the 2x, I'm going to divide it by 2. And if I do that to the left side, remember I have to do it to both sides there. I'm going to take the other side, I'm going to divide it by 2. Don't forget your equal sign. Now this 2 here, that's times the x, and this 2 here that's dividing into it, have that canceling effect. They just cancel out as a factor of 1. I have 1x, which is x. And on the other side, negative 18 divided by 2, a negative divided by a positive is a negative, negative 9, and there's my answer. Now, I'm going to check my answer like I did in the last section by substituting it in and seeing if it gives me a true statement, because that's the definition of a solution. I'm going to check my answer by substituting it back into the original problem. So here's my check. I left myself enough room, that is. This would be 2 times negative 9 equals negative 18. Well, positive times a negative is a negative. 2 times 9 is 18. Look, I get negative 18 on both sides. It checks out just fine. I'm pretty sure I have a good answer there. Now again, for you people that are good at mental math, you had this answer as soon as you saw the equation written down. But again, we don't want you to depend on doing it with mental math. That's a good check. We want you to know the steps and how to write it and how to solve the equation, because as I mentioned in the last section, these equations are going to get much more complicated than what we're looking at right now. The next equation is about the same here as the first one. I have my variable a. It's being multiplied this time by a negative number, negative 5, and it equals negative 60. To get rid of the negative 5 that's times the a, I'm going to divide by negative 5, not by positive 5. I'm not looking for the opposite. I'm looking for the inverse operation, and the inverse of multiplying by a number is to divide by that number, by negative 5 in this case. So I write the side down, I divide it by negative 5, I show that with a fraction, and then on the right side I divide by negative 5. A negative divided by a negative is positive, the 5's are going to cancel, I get 1a, which is a, and a negative divided by a negative here is positive. 60 divided by 5 is 12. And I feel pretty good that that's my answer, but I'm going to check it. Now to check my answer here, I'm going to take the 12 and I'm going to substitute it in for the variable a. Remember, negative 5a means negative 5 times a, so this would be negative 5 times 12. Does that equal negative 60? Positive times negative is negative, yep, and yep, and yep. And I have my correct answer. My check shows I get the same number on both sides. That's a good sign. Now, one of the more tempting things for students to do is to try to do a shortcut step on these equations. They don't want to write this all down again because they already have it here. So what they want to do, what students have a tendency to want to do here, is they want to just put the fraction bars on the original problem and then put the negative 5s underneath. And I'm going to suggest that you don't do that, because later on we're going to be solving using these methods on inequalities, and we're going to be dividing by negative numbers, and you're going to get incorrect statements. So you might as well get used to writing that extra little bit down. It's not going to kill you. It's good practice, and it's much more formal if you write it out this way. Now, back to the examples here. I have 155 equals negative 31m. My variable is m. It's being multiplied by negative 31. I'm going to divide by negative 31, both sides. Doesn't matter that the variable's on the right side this time. We've looked at problems like that before. A positive divided by a negative is negative, and we're lucky it goes in exactly 5 times. Negative 5. And here the negative 31s cancel. And the little slashes there, those are 1s because they cancel out as a factor of 1. 1m is m. And there's my answer. Most students don't put the little 1s down. I do try to emphasize that those are undoing one another, and by dividing, and when you divide a number by itself, you get 1. Now I'm going to check my work. I'm going to plug negative 5 right in here for m. CK again for check. And I have 155 equals negative 31 times negative 5. Now this is going to stay 155 because it's already simplified, but a negative times a negative is a positive, and you can trust me, or you can do it on scratch paper. If you multiply 155, so I get 155 on both sides. It checks out just fine, and I'm pretty good with my answer being m equals negative 5 or negative 5 equals m. Now this is division property of equality because there was something times my variable. Let's reverse this. What if something's dividing into my variable? I haven't looked at a problem like that yet. Well, here's our fourth key property. We've had the addition property of equality, the subtraction property of equality, the division property of equality, and now the multiplication property of equality. If a, b, and c are real numbers, and again we'll make the stipulation that c can't be 0, and if a equals b, then a times c equals b times c. Right here, a times c, ac means a times c equals b times c. Now you're thinking, well, if c is 0, I'll have equality, I'll have 0 equals 0. Yeah, that's kind of trivial, but it kind of wipes out the entire equation. So we're not looking at a value of c being 0. We're looking at c being a non-zero number, if that makes sense. Now in this case, in this first equation, it says to solve here, a divided by 12, that's what that means, over 12, a divided by 12 is negative 3. Since my variable a is being divided by 12, the inverse of dividing would be to multiply by 12. Now, because multiplication is commutative, it doesn't matter if you put the multiplication in either order. I'm going to write the 12 first. Instead of seeing how it's on the end here, I multiply both sides by c, I put it on the right sides. I'm going to put it on the left sides here. I'm going to multiply this side by 12, and I'm going to multiply this side by 12. Now this 12 and a over 12, the whole idea of these 12s are to cancel, and if you think of 12 as 12 over 1, you can see indeed they do cross cancel. And I get 1a, which is a, and then over here I have a positive times a negative, that's a negative 36. In the next example, very similar, my variable is being divided by a number. It's being divided by negative 3. It's on the right side though this time. So the inverse of dividing by negative 3 would be to multiply by negative 3. So again, I put it out first. That's just the way I prefer to write it. Negative 3 times 19, negative 3 times p over negative 3. Well, negative times positive is negative, and 3 times 19 is 57. Here, the negative 3's cross cancel out. Now, a lot of students don't put the little over 1 and then cross cancel and put the 1s. They just cross them out. And this is the idea behind it, and that's why I write it that way. And I get p is equal to negative 57. This one's a little simpler because it's all nice, neat, positive numbers. And again, you can probably do this one in your head quicker than I can write it out. But I'm going to solve this. My variable, using these steps, my variable is being divided by 2. The inverse of dividing by 2 would be to multiply by 2, both sides. If you multiply both sides by different numbers, that's going to mess it up. You're not going to maintain your equality. These give me equivalent equations. The solution to this equation is the solution to this equation, and in this case it is w equals 26. That's my solution. Last but not least, negative 8 equals x over negative 8. I'm going to get rid of the negative, x over negative 6. I'm going to get rid of the dividing by negative 6 by multiplying by negative 6. Now, if you want to put parentheses here so you don't mess up with your signs, no problem. That's probably a good idea. Negative 6 times negative 8 on the left side here is a positive 48. And over here you can see they cross cancel right out of there, and I get 48 equals x. One last example, a little different than the others because it's a story problem. Now I gave you a approach to solving story problems, but in this case, since we're going to use an equation, I gave a modified approach of steps over here. But let's read the problem first. Jack bicycled at an average speed of 4 miles per hour, mph, miles per hour, to get to the post office that was 1 mile from home. how long did it take him to reach the post office? Now make sure that you read the problem carefully. If you don't understand what the problem's saying, go back and read it again. Then we're going to state the variable or the unknown, which in this case is what they're asking for. How long did it take him to reach the post office? So that has to do with time. We're going to write an equation that models this problem. We're going to solve the equation using the methods we've been practicing, and then we'll state our answer to make sure it makes sense. Now in this case, we're going to use this little formula here, distance equals rate times time. Because we know that in this equation, the distance is 1, and the rate is 4. What we don't know is the time, that's the t. So I'm going to over here state t equals the time. So that's the second step. State the variable, t equals time. Step 3, write the equation, which I was able to do because I had a formula. That was very nice. Now I'm going to solve this equation. My variable, my unknown is t. It's being multiplied by 4. The inverse would be to divide by 4. So I'm going to divide this by 4, and I'm going to divide this by 4. Now I'm going to get a fraction. I haven't gotten a fraction yet. In an equation, the 4's cancel on the right, and I get 1/4. Now this is 1/4 time. Day, hour, year. Well, since this was in miles per hour, this is 1/4 of an hour. Now 1/4 of an hour, that's 15 minutes. So I can write it either way. 15 minutes is maybe a little bit better way to say it, but does that make sense? 15 minutes, he can go 4 miles an hour, he's 1 mile away. That makes sense to me. That seems like a logical answer. So it would take him 15 minutes. Now notice how I put the units on my answer. If it was money, I'd have a dollar sign or a cent sign, but in this case it's time. So I have the units of time. That's what I mean by formally state the answer. Write it out like you would be stating the answer to somebody verbally.